let's talk about something that has probably driven you crazy in math class at some point. All those formulas you have to memorize. Well, today, we're going to show you that knowing why a formula works is way better and honestly a lot easier than just memorizing it. So let's jump right in and see how this all clicks together. We have all been there. You know the feeling, right? You're staring at a textbook full of formulas, and it just feels like you're learning all these random rules that you have to cram into your brain for a test. It's that classic pain of rote memorization, and it kind of sucks the fun out of everything. I mean, seriously, does this sound familiar? You're given a shape, you get a formula, and you're just told, plug in the numbers. It can feel totally random and, let's be real, pretty confusing. I mean, just look at this thing. The formula for the area of a trapezoid. It's got fractions, it's got parentheses, 2 different bases. It just looks like a headache. But what if I told you there's a super simple visual trick hiding inside all that complicated-looking math? And that brings us to the big secret for today. The weapon you can use to beat all this formula frustration is an idea called decomposition. And trust me, it's like the secret key that unlocks why these formulas actually make total sense. So what is decomposition? It's actually exactly what it sounds like. It's this simple but really powerful idea of taking a weird, complicated shape and just chopping it up into smaller, friendlier shapes that we're already comfortable with. You know, like basic rectangles and triangles. And that's really the whole secret. That's it. It's a total shift in how you look at the problem. Instead of panicking when you see a complex shape, you just ask yourself one simple question. How can I break this down? All right, enough talk. Let's actually put this secret to the test. We're going to start with a classic shape, the parallelogram. It's kind of slanted and a little awkward, not as clean as a rectangle. Or is it? Okay, so check this out. We take our parallelogram, now just watch. We slice off that little triangle on the left, and then we just slide it right over to the other side. And bam! Just like that, we've made a perfect, easy-to-solve rectangle. And hey, we all know how to find the area of a rectangle, right? It's just base times height. So 6 times 3 gives us 18 square units. See? No crazy formula to remember. We just moved a piece around and used a formula we already knew. Okay, that was a pretty good warm-up. Now, let's take that exact same idea and go back to our main villain for today, the trapezoid. Can our little decomposition secret work on something that looks this tricky? So here it is again, a trapezoid with 2 different bases, a top one of 4, a bottom one of 8, and a height of 5. And there's that complicated formula we saw at the beginning. Now, if you plug the numbers into that formula, you get the answer 30, and that's fine. But the why is the cool part. That formula isn't just some random rule. It's actually a mathematical shortcut. It's doing the decomposition for you. It's basically calculated the area of the rectangle in the middle and the 2 little triangles on the sides and added them all up in one neat package. Okay, now for the grand finale, the ultimate proof that this whole idea is rock solid. We're going to go back to our parallelogram and show that math is always consistent no matter which way you look at a problem. So instead of slicing off that little triangle to make a rectangle, what happens if we slice our parallelogram a totally different way, like diagonally, from one corner to the other? Well, what do we end up with? 2 identical triangles. Now, just look at this. On the top line, the standard parallelogram formula of base times height gives us 18. Cool. On the bottom line, if we figure out the area of one of those new triangles, which is half base times height, or 9, and then add it to the other one, we get 9 plus 9, which is 18, the exact same answer. And this is what is so cool about math. The logic holds up. It doesn't matter if you see it as 1 parallelogram or 2 triangles. The fundamental space it takes up is the same. It works no matter how we slice it. This just goes to show you that formulas are really just a reliable set of instructions. And this idea of using precise instructions to build something is ancient. You can think of it like a blueprint. In Genesis, Noah was given a very specific formula for the ark's dimensions. In the same way, a math formula gives us the precise instructions we need to find an answer. Okay, now it's your turn to be the mathematician. Let's put this new way of thinking to the test with a few quick challenges. Here are 5 quick problems for you. You've got a trapezoid, a parallelogram, a couple of work backwards problems with a triangle and a rectangle, and then one final little logic question. Go ahead and hit pause right here. Seriously, Grab a piece of paper and see if you can solve them using what you've just learned. No pressure. The answers are on the very next slide. All right, how'd you do? The trapezoid area is 16, the parallelogram is 35, the missing height of the triangle is 6, and the length of the rectangle is 7. And for that final question, the total area of the original shape is, of course, 18. So if you remember just one thing from this, let it be this. The goal isn't just to memorize a formula. The real power comes from understanding why it works. When you can see the simple shapes inside the formula, you own the knowledge forever. And that brings us to our final thought. This idea of decomposition isn't just for math. Think about it. What big, complicated project or goal or problem in your own life could you solve more easily just by breaking it down into smaller, simpler parts? Thanks for joining me.